All right, welcome back, everyone. If you're sticking around, so I'm just gonna go ahead and share my screen again, but this time I will be on Onshape. Okay, so we now have Onshape booted up. I'm hoping people are seeing this here. Um, so basically, I'm gonna go ahead and sign in, and I'm sort of just gonna move through. But actually, you know what? I'll even try and see if I can show you the sign up. Like if I go sign in, then it'll probably ask me these sorts of things. Okay. So if you guys are just starting out with Onshape for the first time, so this is just one example. I really like Onshape, as you can probably tell. So you could just go to the sign up page, and you'll want to go for education. So you can go ahead and click there, and then you can go ahead and sign up. Definitely want to pick that you're a student, and they have options for sort of high school or if you're a university student. The advantages with the education plan is that obviously you're going to have more features for free. That's one thing. Number two is that this is like a little more technical, but the designs that you're making on Onshape are actually your own intellectual property rather than just being in the public domain, which basically means that say you make something on Onshape and you're going to make $1 billion off of it, you know, it's actually your property and it's your $1 billion. It's not anybody can sort of access that proprietary design. But yeah, Onshape's education plan is probably what I would recommend for most people. So I'm just going to go ahead and sign in. And this is what Onshape will look like. So basically, to sum this up here, you've got a couple things going on. So you got the last opened by me, so we can just go ahead and close that. Obviously, that's pretty straightforward. You got folders, you have documents. So not going to go 100% into these two. But basically, on the left here, you have recently opened, created by me, shared with me, and teams. So if you're in specific, you can basically do that with also, for example, if you have your one Onshape account and say you're on a couple different student teams and they're all using Onshape, then you could be involved here. And then there's also just public documents. So these are all kinds of things that people have made. Obviously, a lot of them look really cool. But basically, if you just want to start designing something, then you want to go to this top corner. You want to hit create. So to sort of the difference between a document and a folder, or the difference between Onshape that I was sort of mentioning. So let's call this SRIL Part A, and we're gonna hit OK, and we have a CAD interface. Oh, someone just asked in Slido, does Onshape work online, a high-end computer not necessary? Absolutely, that's 100% correct. So Onshape doesn't have a native desktop application. It's purely browser-based. So when you're working on, one thing that would be kind of similar is it's pretty much Google Docs, but for CAD, if you guys have worked with Google Docs. Essentially, you're able to collaborate, and all of this stuff is hosted on someone else's servers. And those servers are basically putting in the work. Well, actually, I guess I'm not 100% the computer guru, so someone could definitely correct me on that. But yeah, basically, it's not your computer that's doing most of the work. It's their computers, which is definitely a great thing because that's going to open you up to different operating systems. So for example, me right now, I'm running all this on a Mac. And as well, it's also gonna, you don't necessarily need a high-end computer to run the software. Okay, so when you open up CAD, this is really similar to basically every CAD software package ever. You're gonna open up CAD and you're gonna have 3 planes, and this is what it's gonna look like. So you have a top plane, a front plane, and a right plane. It could also be a left plane, whatever way you want to look at it. Oh, I see people are drawing. Let's not do that. Thank you. Cool. All right. So how do you just start making a part? So what we're gonna make here is a box. So I know, really fancy. But basically, if you're going to go ahead and create a new sketch. So I know someone asked in the Slido, what do you mean by fully define your sketches? And I'm going to kind of explain that now. So the first thing that you're going to want to do is basically you're making a sketch, which is just a 2D image that you're going to essentially be able to extrude. So almost all CAD software packages sort of look like this. They essentially, you're going to draw 2D images, and then you're going to extrude or use those 2D images to either extrude or remove different parts of your pieces until you basically end up with what you want. Now, obviously, much more complex CAD. So if you're dealing with a lot of surfacing and stuff like that, you're going to end up in different types of extrudes. You might even end up with different kinds of sketches because you're dealing with 3D lines, for example. But that's sort of the basics of CAD. So say we want to make a box that's sort of just like upright and it's box. We're going to go ahead and click on the top plane. So what does that mean? What does it mean that I just clicked on the top plane? Well, that means that when I draw this sketch, and like I said, sketches are 2D, it's going to be like my piece of paper almost, if you can imagine that, is right here on this top plane, right? So this is my piece of paper. If I want to draw something that's going into or out of this piece of paper, it's not going to work because every single part of my drawing is going to be contained onto this plane. That being said, if I wanted to do that, so essentially I wanted to draw a box that was going this way, then I could totally do that, but I would just need to pick a new plane. So yeah, we're gonna go ahead and go back to top. Oh, also, I guess I'm not gonna explain super basic stuff like how to pan around, how to rotate, stuff like that, just because like basically if you go onto Onshape and you sort of start playing around, I feel like most people would be able to figure that out pretty quickly. And another thing I should mention is that Onshape also has pretty decent supporting documentation. So if you're ever to the point where you're kind of going, how the heck do I do X in Onshape? You can definitely Google it and you're probably going to come up with something. They also have forums that you can put out, and generally people will be able to answer that. Okay, so we are now going to that's not what I wanted. Okay, there we go. So now we're going to go ahead and start the sketch. Okay, so what we're going to make is just like a line. So we have a couple of options here. So like I said, we have a couple of options in CAD. So one approach we could take is we're just going to go ahead and draw 4 lines. And obviously, now we have a box. I could go ahead, and now that these lines are closed, I could go ahead and exit out of the sketch, and I can move on. But someone asked me what fully defining my sketches is, and this is what I mean. So when you get into CAD, oh, also this is sort of what I mean, that my piece of paper is on this top plane. So you can see that these lines that I drew are now here. They didn't go through the page. They didn't go in another direction. They're on this piece of paper. So the thing with this method that I just did is that now, if I want to properly define them, you can see that these lines and dots are all blue. That means they're undefined, which means that if I pull on one of these dots, it can move. It's not, everything that's about this box is not specified, in the sense that there are free parameters, if you think of it that way. So essentially what I mean is that if I change one thing, other things will change. So say now I decide that, what I'm going to do is I'm going to go ahead and define the dimension for this line, and I'm going to call it 50 millimeters, right? So now this line, no matter what I do to this dot, this line is always going to stay 50 millimeters away from that line, which is kind of what I mean by there are no free parameters, right? So no matter what I do, I will always keep these two 50 millimeters apart. So that's sort of what I mean by fully defining my sketches, is that if you pull on one of these parts, if you change one thing, not everything else is going to change in a complete way that you didn't expect or you didn't see coming. So now If I go ahead and dimension this side as well, I want this 50. But another thing we're going to notice is that this is tilted. Now that's going to get fixed just by nature of this 50 dimension. But if I go ahead and delete that, another way I could have fixed that. So now we can see, oh shoot, I changed this dot line and now this line is moved. Again, because the sketch isn't fully defined, you can use relations between lines. And I know I'm going a bit fast, but hopefully once you start playing around with this yourselves, you will sort of be able to sort of get a picture of this. But these relations are basically how I can tell a sketch what I want certain entities, for example, this line, to do in relation to other entities. So, for example, this line. What we want is we want this one to be parallel to this one. Another alternative way of doing that is saying that this line needs to be perpendicular to that line. Same thing. So we're going to go ahead and click on this parallel dimension, or relation, sorry, and we're going to tell that this is parallel. And now, again, no matter what I do to this, you'll see that it's going to move in a predictable way. It's going to move, closing these two lines closer together. And that's because now we're defining our sketch. If we go ahead and we now say, put a dimension on this one right here, and we also call this 50 millimeters, ta-da. Now, if I go ahead and move this, now the whole box is going to move. Why? Because this sketch is getting more and more defined. Moving this one point, like if you remember when we moved this point, this line was closing in, and that wasn't exactly what we wanted. What we actually wanted was to be able to move it and straighten out this line. So lastly, the reason why this sketch isn't fully defined is essentially there's no relationship between this, this square and another part of this drawing, so it can sort of move around as is. So if, for example, we say that this point needs to be 25 millimeters away from that point, now you can see that these lines turn black, which means that these lines, these sketch entities, are fully defined. So no matter what I do to this, it's not going to move. The only way I can actually move this part is by changing one of the parameters or one of the specifications that I've already set into the part. So we can go ahead here and say this part is not like this. There we go. Okay. There we go. So we're going to say that that is also 25 millimeters away, and now everything's gone black. So now the only way I can go ahead and change this part around, say I come back in the future and I need a design change, I'm going to go ahead and change this to a 40 millimeter by 40 millimeter square. Now things are moving around in the way that I expect. They're going to go ahead and move this, right? So now I can very quickly and easily change this box to 40 millimeters by 40 millimeters. So it's very important to go ahead and always fully define sketches. And that's why. It's because when you change things, you want them to be able to change in the way that you expect, so that essentially you don't break your part, which can definitely happen. Another thing that you don't want to do, however, this part is now perfectly constrained. However, you can see if I tell this part now I want this to be 30 meters away from this, everything's going to go red, and that just means that it's over-defined. The sketch can't be solved, I think in SOLIDWORKS is the way they put it. And that's because, well, it's impossible to solve this. I've said that this needs to be 40 millimeters long, but this side is 30 and this side is 20, like between the two things. So it doesn't make sense. It's pretty much what it's telling you, which means you need to go look for the dimension that's not following the design intent of what you're trying to make. Okay, so now we're going to go ahead and click up here on this check mark, and ta-da, we have our square on the top plane. So the last thing we need to do is turn this into a box. So we're going to go and click up here, and we're going to go extrude. Oh, I forgot to do something. I forgot to rename this sketch. So we're going to call this rectangle on top plane. Another way to do this would be to call this the base sketch for box extrude. So when I come back, I know, okay, so what is this? This is the base sketch for box extrude. And another thing that you'll see, or I guess this will make sense. I'll cover that in a sec, actually. So if I go top, go to my top view, and I say it's asking me for the faces and sketch regions to extrude. So I'm going to tell it that that's what I want. Alternatively, instead of selecting it here, I could have said, okay, I want to extrude this base sketch for box extrude, same thing. And I'm telling it blind, which essentially means that I just want it to make the extrude. I don't want it to care what other stuff is there. I just want it to extrude. And we're going to say, since we made it 40 millimeters by 40 millimeters, we're going to call the depth 40 millimeters. Hit this check mark, and we have a box. Amazing CAD. But yeah. So now we managed to make our box. We know that it's 40 millimeters by 40 millimeters. And another thing that we'll see, so let's call this box. Another thing that we'll see is that if we go ahead and click here and say, now we're going to roll back this part, we're going to say, okay, well, actually, we had it right the first time. This should have been 50 by 50. And these two guys are also going to be 25. Now, if I hit check mark on the sketch, our box has actually turned into, believe it or not, a 50 by 50 box. I mean, now we have to go and edit this and make this 50 to make it actually a cube. But regardless, everything's fixed. So now you can see what I mean. And the other thing is why I was telling you guys, like, you know, you want to always fully define stuff and what it might look like if you break your sketch is now let's say, okay, I'm going to move this. So what I'm doing here is I'm going to roll this forward past the box. Well, now this box is broken because there's no sketch. I guess to make sense of what I just did, essentially this bar here is telling it the order that things were done in. So I told it first, if it's in this order, I told it first I define this base sketch, I made this, and I want you to extrude based on that base sketch. Do this the other way around. Now I'm telling it I extruded a box and then I made the base sketch. That doesn't make sense to the program. It can't figure out where the sketch region is that I'm actually extruding. So it's important to name these parts because definitely in complex designs. So if I show you guys, for example, you might be able to see this. So this is a project I worked on with UBC UAS as well. You know, you generally, so this is actually a canopy for an aircraft, as you can see. So you can see that stuff, you know, as you get even not necessarily the most complex of parts, stuff starts to get pretty complicated, right? On this left-hand side, you can see all the features we have. And say I'm going to change one thing, it can ruin your entire part, right? So if I change this thicken over here, hopefully that breaks everything to illustrate my part, my point. Well, you can see it's really thinking. All right. Anyways, basically my point being that it's going to break everything. And that's probably why it's thinking a ton, is because that probably makes zero sense. There it is. So now you can see that, okay, now the cutouts don't make sense and the ribbing on the inside doesn't make sense anymore to the program. Something's wrong here. And now I got to go fix basically like everything. So we're just going to put that back. Hello. Thank you. And yeah, so that kind of illustrates what I mean by you want to fully define your sketches and you want to name things. It's just good practice because if you're ever coming back and looking at how you made things, you definitely want to be able to see what happened. Okay, sort of to get on to, but yeah, so I guess for this box, this is pretty much like how most things are made in CAD. So this is what you'd call a part now. So you could go ahead and import this into assemblies. Now, assemblies are a little bit more complicated, but essentially assemblies are just a group of parts, if that should hopefully make sense. So what I could do is I could then model up this box. And if I want to have, say, 2 boxes, I could go to an assembly down here on the bottom and go ahead and insert this part. And then say I want to see, okay, well, do these actually line up? I could insert actually another one of these boxes and click this check mark. And now you can see, well, we have 2 boxes. I know it's not the coolest example, but hopefully you're getting the picture. And then you could go ahead and make these 2 boxes together in the way that you would intend for them to work together. Assemblies in Onshape are a little different from SOLIDWORKS or other, I guess, more industry softwares. So that's something to watch out for. But I think generally you'll still be able to get the principles, like you'll still be able to use mates and understand what mates are and how assemblies work. And the other thing is, I think most other software, so say you go into Fusion 360, that's another option. You would be able to go ahead and do all the assemblies similar to SOLIDWORKS. Okay, so going back to parts, pretty much what I wanted to illustrate with this example is sort of how things are done in CAD. It generally looks something like that. You're going to create a sketch and you're going to extrude or cut from that sketch. And then you're going to build more sketches. So say you wanted to put a box or a triangle on top of this box, you could then sketch on the surface of here, and you get the picture. We sketch a triangle, and you know, we'd extrude it, etc. Or we could cut into it using a different extrude feature. So basically, if I go to extrude, you can see remove is here. That's another option. Now, one other thing I wanted to mention about this sketch was that there are numerous ways you could have done this, right? You could have defined these as perpendicular, which was one thing I mentioned. You could have dimensioned different parts of the drawing to get the same effect. For example, you could have dimensioned that. And one thing I said is that simpler is always better. So another way you could actually do this whole thing that's a lot faster is you could have just gone in here and picked center point rectangle, right? Clicked on the base here, and now we've got a rectangle. And I can pick that this side is going to be 50, and that this other side is going to be 50. And now we've got a fully defined rectangle that's or square that's not going to move. Go. So that's another thing to notice, is that say I know for sure that this is going to be a rectangle or a cube or a square, this would have been the better way to do it. Why? It's faster, it's easier, and say I want to change, if you guys remember, in order to change the length, I had to change 4 dimensions last time when I drew it with the lines. This time I just have to change these 2 dimensions. Okay, so maybe the last thing I'll sort of talk about as well is supporting geometry. So you guys can kind of get the picture here where if, or I guess the last thing I'll talk about within CAD, I'll also talk a little bit about PDM. But another thing you'll notice is that say I wanted to build a sketch over here, that's very easy. But like, what am I supposed to do if I make a CAD part and I don't necessarily have a surface to draw on? That's where reference geometry comes into play. So as you can see, we started with these 3 planes, which I sort of pointed out when we started out. You can make your own planes that you can go ahead and draw. So for example, if you don't want to draw on any of these ones, you can go ahead and make, like, say, a 45-degree plane that goes in a different direction. How you might do that is you can go through here. So you've got all sorts of advanced features, which I definitely don't have time to go into all of these. It's a bit beyond our scope here. But for example, planes, which was the example I was just talking about, you could go ahead and even select a plane, like one of these planes, you wanted to draw on there, and you could offset it and make new planes. There are lots of other options. For example, if you pick line angle, you can pick a line and an angle, as straightforward as that is, and do that. Now, reference geometry isn't limited to planes. There's offsetting surfaces. Another thing with parts that you'll find is modifying, like, fillets. You can pattern parts, mirror parts, but yeah, this is a CAD suite that I think is relatively beginner friendly. And as well, it's generally free to most students, or it should be. And yeah. So last thing to talk about, I guess, is PDM. So now we have this document, right? What do I want to do if other people want to work on it? So I think a lot of people asked questions about that earlier today. If I go ahead and I go to the top here and I say I want to share this part, I can go, or sorry, this document. So in Onshape, documents are going to house both parts and assemblies, and all the parts that go into this assembly is really easy. So you can go ahead and do that. So basically your document is all of the files that are related to a specific design or a specific part. So you can go ahead and share this whole document with a team. So for example, you can make a team and like everyone can go there. You can share it to the public, like we saw those cool other projects that were there. You can share it to an individual. So an individual can then sign up for an account and then go ahead and work on it. And I think someone also asked earlier, like, what about version control? Onshape has this built-in version control where you can create branches, create new versions. So we can call this new version V1. We have a box. And say we needed to revert the version later or make changes, we can go ahead and do that. And then when we go back out into our main menu, we will have documents. So for example, say we had all of our parts and all of our assemblies for a very specific design. For a car, for example, it would all be in this document. Another thing is that say you make a mistake and you have two documents that you need to work from, you definitely can insert elements from other documents, etc. I guess one other thing is that you might have noticed create drawing is over here. So if you had a 3D part and you wanted to create a drawing, that's a very basic look into Onshape and doing CAD on Onshape. So if you don't know where to start and you really want to get started with CAD or 3D printing, you can go ahead and do that. If you wanted to, for example, create a 3D print out of this, you could then go ahead here and hit export. And like I said, you're going to take that into an STL file. Take the file and you can take that to a printer and you can go ahead and print a box. So I think we have a couple questions here. Do engineers use, computer engineers use, question just came in. So do computer engineers use CAD often? I don't think necessarily as much as mechanical engineers or civil engineers or other disciplines necessarily. If you're on the hardware side, you might use CAD for example, electrical design. I think I saw that, like SolidWorks, I think, has electrical design. There's one other that's not coming to my mind that's really popular. Oh, Altium for like circuit design, which I guess is technically CAD. So yes and no. If you're like a software developer, I feel like you probably wouldn't use CAD all that much, but it's possible. Yes, I can absolutely show you how to export and what software you would use before printing. So say we're going to go ahead and take this box and we're going to go ahead and print it. So we're going to go ahead and call this box. We can go ahead and export, right? Like I was saying, and then we can go ahead and we're going to say that the units are in millimeters, and we're going to download it, and we're just going to call this box. So we click OK, and I don't think you guys can see that, but I guess you might be able to. So that popped up as an STL file here. Now I got to figure out, I don't know why my e-drawings. So in order to view the print beforehand, there's generally a software called e-drawings. I believe it's available online. For some reason, but another thing that you can actually use to view it is actually Onshape. So if I go ahead and import on this side and go to my downloads and I pick box and I say choose, it's going to ask you, okay, what are the units? What does it look like? So we're not going to create a composite part. We're not going to orient with the y-axis up, and our units are in millimeters. So we're going to say, okay, it's importing. And we can see here, we have CAD imports box STL. Oh, man. Well, that's a bit of a glitch. Okay, well, either way, that should normally pull up a preview. But I will also mention one last thing that I actually don't have the software installed on my computer. But there is, and now I've forgotten the name as well. Not Credo. Let me see if I can just pull this up. Cura, that's the one I'm looking for. Okay, so Cura is the software that you, Ultimaker Cura, that you generally will use to preview sort of like 3D printing, 3D printing prints that you're gonna make. So you would generally take this STL and put it on either a flash drive if you don't have it on your computer, or if you have it on your computer, then you would have Cura. So I apologize that I can't actually show that to you because I don't have it on mine right now. But what ends up happening is, I wonder if I can even show you just screenshots. There we go. That's exactly what I'm looking for. So what ends up happening is that it sort of looks something like this. Nope. Open image in new tab. That's what I want. Yeah, so it looks something like this, where essentially you see this part within the print space that's actually, oh my gosh, within the print space that's actually in your printer. So you can load different printers that'll have different print space. You'll be able to, depending on the printer, set different, like tell it what material you're using, whether that's PLA or ABS. Set your layer height, which we kind of talked about. So in FDM, you have these layers, these plastic layers, so you can make those smaller or larger. Like obviously having smaller layers or more layers is going to make it a better part, better quality part. Whereas having like only a couple layers, essentially the separation between them is going to be very large. So you're going to have a lot less. It's going to be a less dense part. Infill is another thing that you can check. So like when it's actually filling in the insides of the part, how much material is it using in there, whether that's 50% or 100%, and that sort of will just determine what it looks like sort of on the inside, and how structurally rigid it is. But yeah, so Cura is the software that you'd use. It'd be Ultimaker Cura, and you would load it in with that button actually in there. You'd load in the STL, and then you can move it around the printer depending on whether you want to print it on the middle of the bed, etc. You can mirror it, so you can print multiple parts, rotate it, maybe make it fit. If it's not, move it around, etc. So that's sort of what that would look like after you would export it. Kind of sad that Onshape didn't do what I want. Not boding well for it. All right. Anyways, so yeah, I'm going to click on that. And sorry, just to wrap up, we actually have 2 more questions on here. I think one of them is older, so hopefully that person is still in the session. So what personal projects would you recommend for someone going into mechanical engineering? I don't know if there's necessarily like a very specific project. I think it's mostly what you're interested in. So if you're really interested in cars, one really cool project would be to sort of try and model, like, for example, or print an RC car, and then maybe make that run with like electronic motors, and even like a smart controller, like a Raspberry Pi, or a microcontroller like a Arduino, or a microcomputer such as a Raspberry Pi. So that might be a really good project. If you're really interested in naval, you can kind of get the picture. Like you might be able to model up a ship, print that out, and see like what that might look like. I've seen definitely people have made like steam engines, which are kind of cool. If you're really interested in aircraft, like drones, you can definitely like even assemble drones, get a feel for how they work. 3D printing a drone would be kind of difficult, but actually, like, if you could do it, that'd be a really cool project. So yeah, I think it's not necessarily an individual personal project, but mostly what are you interested in and what do you want to do? And what does that relate to, like, sort of the career that you're looking at, or the like the industry that you would look at in mechanical engineering. Another thing that's actually kind of a nice project is always, and that's something that's really easy to do if you don't have a lot of stuff around you, is CAD. Like, you can practice CAD. So like, again, modeling things you're interested in, or practicing like scripting. So if you're, a lot of people don't, I guess, assume that you would want to use scripting all that much in like mechanical engineering, but having a knowledge of like sort of some very basic scripting languages, even whether it's VBA or like Python or something like that, can be really helpful to sort of automate tasks, and as well, like analytical design with MATLAB is another thing that's kind of useful. So doing like a project, definitely not going to get into MATLAB 100% right now, but doing a project like modeling up a car and maybe doing like some kind of analysis on it, tons of resources with MATLAB are available. Even if it's really basic, would be a really cool project. Someone asked how much of a crossover is possible between these softwares. Can SOLIDWORKS files run on Onshape? Yep. So if you click on insert new element and you go import, I don't have a SOLIDWORKS file on me right now, but you can actually import SOLIDWORKS files. The one thing you might find is that some SOLIDWORKS files, like, you might not be able to 100% edit the file as well. So I think Onshape actually allows you to edit the SOLIDWORKS file on here, but certain dimensions, if it's fully defined and stuff like that, sometimes there are glitches. But say you're making an assembly and you have a SOLIDWORKS part and you want to just import it and include it in your Onshape assembly, you can definitely do that. So to sort of illustrate the point, UBC UAS actually used to have a bunch of SolidWorks parts that when we transferred over to Onshape, we imported all those parts in. So for example, this is a flight controller that we frequently use. So if we wanted to model around it, so this is actually just a SolidWorks part in here. So you can see that it's, I don't think I can, oh, I can edit it, but yeah, no, it doesn't really work. So depending on the SolidWorks part, sometimes it works, sometimes it doesn't, but we can definitely include it here and model around it and model with it. And I think that's the same with like just generally most features. Okay, so that's pretty much everything from me. We're just hitting 5 p.m. So if people have other questions, I'll definitely send the slide deck through SRIL, and people are definitely free to email me. I hope I've answered most of your questions and that this was useful for you guys, and that you found this interesting. So thanks for sticking around till the very end. And I don't know if Sophie or Clement want to mention anything, but I think that's pretty much everything from me.
Thank you so much, Adam, for your phenomenal workshop. On behalf of our entire team, thank you and everyone for joining us. This workshop would not be possible without you being with us here today. SRIL is a rapidly growing youth organization specializing in robotics and STEM education. For more information, please go to our social media and website. Have a great day, everyone.
Bye, everyone. Thanks for coming.